All right. So suppose the cost function of a firm in a perfectly competitive market is given by, so we've been given our total cost function here, 10 plus 2q squared, and the market price is 40 kwacha. A, determine the marginal cost. All right, so this is how we're going to do it. Let's make room here. Okay, let me just erase this part. So basically what's going to happen is this. The marginal cost, as we said earlier on, is the additional cost you incur when you produce an extra unit. Now, mathematically, that can be represented as the derivative of the total cost function, okay? A function, colleagues, remember, it's a mathematical relationship between two variables, all right? So we've been told here, our total cost function, we've been given TC equals 10 plus 2q squared. 10 plus 2q squared. All right. So yes, this cost function is just showing the relationship between the quantity you produce and the total cost you incur. All right. Yes, that's what the function is telling us. Now your marginal cost is the derivative of your total cost function. So you're going to say marginal cost equals the derivative of the total cost function. You're going to write it like this: dTc over dq. So what we're saying in simple words is this. We're deriving our total cost function with respect to q. So remember, with differentiation, if a number doesn't have a letter, especially in this case, if it doesn't have a q, it disappears. So this 10 will disappear. So we need to derive 2q squared. Remember, with differentiation, multiply the exponent, the power, with the number in front of the letter. So 2 times 2, that is 4. Then subtract a 1 from the exponent. So we have 4q to the power 2 minus 1, 1. So our marginal cost is 4q. Okay. So what this is telling us in simple words, colleagues, if you produce 1 unit, okay, if you produce 1 unit, the marginal cost is going to be 4 times 1, it's going to be 4. This will be the additional cost. If you produce 2 units, the marginal cost is going to be, you substitute q with 2, 2 times 4, 8. The extra cost is going to be 8 kwacha. That's what this is telling us here. So that is our marginal cost. All right, we go to the next part. It says, derive the total revenue and profit functions. All right, so total revenue function. So total revenue, TR, total revenue, remember it is price times quantity. Okay. In this case, our price, the price they gave us in the question is 40 kwacha. Okay, so price is 40 and our quantity is just Q. Okay. Yes, quantity is just Q. So you're going to say 40 times Q, total revenue function is 40Q. Then the profit function, profit equals total revenue minus total cost. Okay. Profit is total revenue TR minus total cost. So our total revenue was 40Q minus total cost, put it in brackets like this, 10 plus 2Q squared. All right, so our profit function is going to be 40Q. So you're going to say negative 1 times 10, that is negative 10. Negative 1 times 2Q squared, you get negative 2Q squared. Okay, this is the profit function. Okay, so just remember this formula. Yeah. Total revenue price times quantity. Okay, if they haven't given you a value of Q, like if they don't tell you in the question Q equals whatever, 2 or whatever, 5 or whatever, then just know when you're getting your total revenue function, you just leave Q as it is. Then your profit function, total revenue minus total cost. Yes. The question is now asking what level of output should be produced to maximize profit? So this is the point of profit maximization. Okay, and we say the point of profit maximization is where marginal revenue equals marginal cost. Okay, you produce the quantity where marginal revenue equals marginal cost, and that's when you get your highest profit. So we already have our marginal cost here, it's 4Q, but we don't have our marginal revenue. So marginal revenue, which we said is the additional revenue you get, the extra revenue per unit. Okay, extra revenue per unit. That is your marginal revenue. So marginal revenue, mathematically, it is expressed as the derivative of the total revenue function. So we're deriving our total revenue function with respect to Q. So I wrote dtr over dq. We're just saying we're deriving this function here, this 40Q function, with respect to Q. All right. So when we derive 40Q, remember this is 40Q to the power 1. Okay. When deriving, remember you multiply the exponent with the number in front of the letter called the coefficient. 1 times 40, that is 40Q. Subtract a 1 from the exponent. 1 minus 1, that is 0. So you have 40Q to the power 0. Now if you remember in mathematics, anything to the power 0 equals 1. So you don't need to represent this 40, that Q there. So what this is telling us, colleagues, when we sell an extra unit, we get an extra 40 kwacha. Okay, if you sell 1 unit, you get an extra 40 kwacha. You sell another unit, you get another extra 40 kwacha. You sell another unit, you get extra revenue of 40 kwacha. So now we're going to equate. Okay, marginal cost 4Q equals marginal revenue 40. So divide both sides by 4 to get the value of Q. 40 divided by 4, that is 10 units. So this firm must produce 10 units to maximize profit. Okay, the firm must produce 10 units to maximize profit. Okay, yes. In the next part, how much profit will be earned? So if we produce 10 units, how much profit will be earned? So we'll go back to our profit function. P equals TR. Oh, we already have it here. P equals 40Q minus 10 minus 2Q squared. So where there's Q, we substitute it with 10. So we're going to say here 40 multiplied by 10 minus 10 minus 2 times 10 squared. Okay. 40 times 10, that is 400. 400 minus 10. 10 squared, that is 100. 100 times 2, that is 200. So 40 minus 10 minus 200. So we're going to say 400. 400 minus 10 minus 200. 190 kwacha. So this is the maximum profit this firm is going to earn if it produces 10 units.